All of the technology inside of our computers creates heat. One of the best ways to cool off the inside is to pull cool air through the system using fans. It's very common to pull cool air into one side of a case, have that cool air pass over the much warmer components inside, which of course heats up the air, and the hot air is expelled out the other side of the case. The layout of devices on the motherboard and the other components inside the case all contribute to how well the air can flow through this particular case. You want to be sure to make sure all of your wires and other components are out of the way and that you have a good airflow to pass from one side of the case to the other. There are many different types of cases, many different types of cooling systems, and all of these work together to provide you with an optimal form of cooling. If you look at the different adapter cards inside of your computer, you may find that the cards themselves have their own fans. This takes the cool air inside of your computer and directs it to a single point on this particular adapter card. It's very likely that the components of this particular kind of adapter card get very warm and need this additional cooling of an onboard fan. Of course, to support this onboard fan, we need enough room, so you may find these fans are only used on larger adapter cards. Very often you'll find these types of fans on high-end video cards or graphics cards. The fans that are installed onto the case of your computer come in very standard sizes. You'll often find 80mm, 120mm, or 200mm sized fans. These fans are often variable speed, so they'll run at slower speeds while your computer is cool, and then run faster and faster as your computer heats up. This means that as the fans go faster, the noise gets a bit louder, and you can find different types of fans from different manufacturers that have different amounts of audio output. This is important, especially if you're in an environment like I am, where you want to be sure that everything is as quiet as possible. One of the best ways to avoid any fan noise is to avoid the fan completely. To be able to cool these systems, we use a fanless system, or what we call passive cooling. You'll often see passive cooling used in areas where you'd like the system to remain quiet. Things like a video server or a set-top box on top of your television are perfect places to have passive cooling. You often see this type of passive cooling used on purpose-built appliances and devices where the amount of heat can be easily managed. And this is very often used in conjunction with a heat sink to be able to take all of the heat from an individual component and spread that heat out over a much larger area. Heat sinks are critical for dissipating heat inside of your computer, and it's very possible you have many different types of heat sink in the system that you're using right now. These work by taking the heat that's on a component and spreading that heat across many individual fins, effectively increasing the surface area for cooling. As the air passes through these fins, it transfers the heat from the fins to the air and begins the cooling process all over again. If you're working inside of a computer that has a heat sink, be very careful about touching them. They get very hot, and it's very easy to burn yourself if the system has been running for any amount of time. You also want to make sure that you have the proper amount of thermal paste so that you have a good thermal connection between the very hot component and the heat sink itself. You might also hear thermal paste referred to as thermal grease or conductive grease. This is an adhesive you put on top of the hot component so that you can fasten the heatsink to the top. This also creates this thermal connection between the hot component and the heatsink. And since you're usually placing the heatsink directly on top of the component, it usually doesn't take much thermal paste to be able to make a good connection. Usually it's a pea-sized component, and that's all you'll need so that it flattens out and distributes itself evenly over the hot component. Another good form to create a thermal connection is to use a thermal pad. This is the pad that you see here that you would put right on top of the hot CPU or the hot component, and you would place a heatsink on top of the thermal pad. You would usually use a thermal pad when you were concerned about thermal paste perhaps leaking out and damaging other components. The thermal pad is not quite as effective as thermal paste, but it still makes a very good connection between the hot part of your computer and the heatsink. And like thermal paste, the thermal pad is not reusable, so if you do remove it, you'll need to replace it with a new one when you put on the new heatsink. These are certainly less messy to install than thermal paste, and you would usually put the heatsink right on top of the thermal pad. And if this is a CPU, we might have a CPU on the bottom We might have thermal paste or a thermal pad on top of the CPU. We would then put a heatsink on top of the thermal pad or thermal paste. And then on top of that, we might include a fan just to make sure we're getting plenty of cooling all the way down to the component. And if you need a larger fan, you might want to put it sideways so your CPU is still underneath. You would have a heatsink on top of that CPU and then a much larger fan that blows air through that entire heatsink. Well, if your fans are making too much noise or they're not providing enough cooling, you might want to consider liquid cooling. This is the same type of cooling you might find in an automobile or in mainframe computers. Usually you would have liquid cooling on high-end systems, but we're finding that liquid cooling is perfect for things like a gaming computer you might have at home. You might also see this liquid cooling used when someone is overclocking their system to try to get as much performance out of their processor as possible. This liquid cooling system usually consists of the heatsink that sits on top of the processor. There are pipes that take the coolant over to a set of radiators that often have fans blowing through them. Once you place that transfer unit for the heat on top of your CPU, you can then have all of the liquid transfer between the CPU itself over to the radiator, have the air blow through to cool off the coolant, and then return the coolant back to the CPU.